Hello everyone, this is Vasant, a nine-pointer at IIT Bombay from the Department of Civil Engineering. In this video, we are going to start a new topic called torsional loading. So in previous few lectures, in couple of lectures, we completed axial loading. Now we are going to move to torsional loading. Before starting this topic, we need to know why we need to study this topic. So torsional loading, like axial loading, will cause some internal forces. We already said that any load will cause some internal forces and deformations, so which may be critical for some members. So to design structural elements, we need to ensure it won't fail under any load it may be subjected to at that place, including torsional loading. So for that, we need to understand the torsional load. So now first, what is torsional load? Torsional loading is, if we take a member, take the cross section of the member, principal plane of the member, then if you apply the moment, equal and opposite moment, about longitudinal axis, then that type of moment is known as twisting moment or torsional moment, and that load is known as torsional loading. So this is longitudinal axis, right? So let us discuss about representation. Before going to representation, how can we apply a torsional load in real structures? See, we are saying that in this case I apply torsional load using hands, but in big structures, how you apply torsional load? The basic idea is they attach a member like this. They will attach member like this, and they will apply equal and opposite force P at the ends. So if you see, for this member, if you take this member, it is in force equilibrium, but if you take this is D2, so it is creating P2 into D2 movement M2, right? So this movement is restricted by this connection to this rod. So here it is creating this moment. It will restrict by this moment M2, right? So on the rod we will get this type of moment M2, right? Similarly here there is rod, so the moment created by it will be P1 D1, and it is restricted by this rod, right? It is trying to rotate this rod in this direction, so the moment on the rod will become like this, that will be equals to P1 D1. So this is one type of representation, and this one is another type of representation, like this and like this. Another type of representation is this one, two-headed arrow, double-headed arrow. So using right hand thumb rule, if the movement is like this and your thumb is facing like that, then double-headed arrow should face like that, in that direction. So if it is rotating like this, then double-headed arrow will face in this direction. So the direction of double-headed arrow will be in this direction, right? So for this movement, the double-headed arrow will be in this direction. For this moment, the double-headed arrow will be in this direction. Okay. So I think you understand how we represent the torsional loadings. So now circular bar under torsion. So torsion is trying to rotate the elements, right? So if you mark the checker lines on these circular bar, this is the circular bar, you mark the checker lines and you apply equal and opposite torque T. Then if you consider two particles over here, A and A dash, and if you go and see over here, they will go like this, right? They will be on same circumference. The particles will remain on the same cross section, right? Cross-sectional circumference. Just they will move on the circumference. So that is about circular bar under tension. You take rectangular bar and you try to do torsion to it. See, if you take this rectangular duster and you will try to do torsion, see, it will go out of the plane, right? The elements will go out of the plane. But in case of circular bar, the elements will be in the plane. So in case of these things go out of the plane. So this phenomena is known as warping. But in case of circular members, as they are symmetric, there will be no warping. So we only deal with circular members in this chapter. So now what is pure shear condition? See, if you observe, if you take one box over here, initially the box is like this, and after application of the torsion, the box is changing like this. The lengths are almost equal, but the shape of the box is changing, means the angle is changing. That means it is in shear, but no other loads. So it is in pure shear, right? So only shear forces are acting here. So it will have toe like this, and this plate like this, so toe like this, like this. Okay. So this is pure shear condition. So torsional loading is creating shear forces. Okay. So let us write one thing. Torsional loading creates shear. Shear means change in angle, right? So this is about basics of torsion. So we said that one is the case of warping, another is a no warping. In these type of materials, there will be warping, and in circular bars, there will be no warping. So we generally deal with circular bars. Okay. With this, we end today's lecture. In next lecture, we are going to discuss next few concepts of torsion. Thank you.